This chart is about a law known as Swanson's law, which conceptually is similar to Moore's law, but is less well known and got coined at a much later time. But it's very important because Swanson's law projects out the rate of photovoltaic electricity generation and at what point a substantial percentage of the world's electricity is generated through solar power, more specifically, the conversion of sunlight into electricity. So here's how you look at this graph. This vertical axis is logarithmic in nature, meaning each interval of a certain size is a doubling of this dollar price. Price per watt of solar photovoltaics. 50 cents per watt, $1 per watt, $2 per watt, 5, 10, 20. The distance between 5, 10, 20 is the same as the vertical distance between 50 cents, $1, and $2. That's how a logarithmic axis works. This horizontal axis is also logarithmic, but in terms of megawatts of cumulative installed solar PV capacity. So as this goes to the right-hand side, these are in orders of 10 times more for each of the major grid lines. And this trend line is the trend of these actual data points per year. So starting from 1976, the very beginning of the earliest photovoltaic cells, when very few were ever installed because it was more than $100 per watt. This declining line shows how the price per watt has been going down per year. And as the price goes down, it's easier and easier to install more solar farms. Therefore, the installation of megawatts of PV capacity continues to rise. So each year represents the price for that year and the cumulative installed capacity up to that point. Now, photovoltaics have been my very first exponential technology. When I was 10 years old, I wrote a paper with a pencil, a number 2 pencil, in my elementary school, and I wrote it on those wide-ruled sheets, not those college-ruled sheets. And I wrote a paper about how solar power was getting 5% cheaper a year per unit of electricity generation, a watt. And therefore, by the 2020s, solar energy would be a mass market technology generating a significant percentage of all the world's electricity. So I projected that out 40 years ahead when I was 10 years old and I wrote a paper in the 5th grade. And that paper was sent to the principal of my school, and that was sent to the superintendent, and then me and a bunch of other 10-year-old kids from other schools were rounded up and invited to meet the mayor of Cleveland at that time. I was living in Cleveland, Ohio, George Voinovich, who later became a U.S. senator. And we were kids and we didn't understand why meeting the mayor was important or anything. We were just happy that they had cookies there. But yeah, I got to meet the mayor of Cleveland because I wrote this paper about photovoltaics when I was 10 years old. This photo was from the 4th grade, so about a year before that paper was written and submitted, but you get an idea about how the world was at that time. And you can see which one of the kids is me. But anyway, I wanted everyone to get familiar with this chart because this tells us how far we have come with photovoltaic power. It was just a theoretical pipe dream in the 1970s and 80s. But after decades of gradual improvement through Swanson's law, we are now at a point where 1 million megawatts, a terawatt of photovoltaic power, has finally been installed as of 2023. And 5 to 6% of the entire world's electricity is now generated through solar, so we're very close to a tipping point. Within this decade, the 2020s, we will get to double digits on that number, and I'm satisfied if we get to double digits. If 10, 11, 12% of the world's electricity is generated via solar, I am satisfied, even though it will keep improving from there. That took thousands of years of human civilization and centuries of engineering and decades of Swanson's law charting this progress, exponential trends within exponential trends, to get to this point where now a substantial amount of electricity is finally being generated by solar. Thanks for watching.